over 4 all raised to the power of what? T minus 1. Now looking at this question, you will think it's very, very difficult for you to answer. But the idea of exponential function or exponential equation that we have known before is still working for this. You want to ensure the base you are having are the same thing with their indices present there. When you have the index at the right hand side, you have the index at the left hand side. Then the bases are made to look alike, then they will divide, they will strike themselves out, then the index can remain to get your answer. But if you look at what we are having there, the left hand side and the right hand side are not even looking any way alike. So we have 64 over 27 equals to 3 over 4 all in the bracket of what? All in the bracket of 3 over 4 raised to the power of what? T minus 1. When you have that, the only thing you want to do is that we can make this one look like this one. Then carve out its own index, then from there we can move ahead. What do? This 64 is the same thing as writing 4 raised to the power of 3 over what? 3 raised to the power of what? 3. Why? Because 4 times 4 times 4 will give us what? 64. 4 times 4 is what? 16. And 16 times 4 is what? 64. The same thing here. 3 times 3 is what? 9. And 9 times 3 is what? 27. So it means that instead of writing 64, I can represent it with 4 raised to the power 3. Instead of writing 27, I can represent it with what? 3 raised to the power what? 3. So which is equals to 3 over 4 all raised to the power of T minus 1. We are getting there gradually. Now we have seen 4, we have seen 3. Here we have seen 3, we have seen 4. But it's just that one is in the numerator, the other one is in the denominator. One is in the denominator and the other one is in the what? Numerator. At both sides, at the left hand side and the right hand side. Now according to our law, since I'm having this 4 to be a power of 3, this 3 is also in the power of 3, which means there's a similarity between the numerator and the denominator. I can place them in a single bracket to give me 1 over 3 all raised to the power of what? 3. All raised to the power of what? 3 equals to what? 3 over 4 raised to the power of T minus 1. We are getting there gradually. Now we have succeeded in making this one 4 over 3 in a single bracket, and this one still remains 3 over 4. But before we can work with exponential to get our unknown that is present in the index, we need to ensure this one is looking like this one. So if that be the case, we can take reciprocal of the left hand side. Taking the reciprocal of the left hand side. So taking the reciprocal of the left hand side, what am I going to have? I will have 3 over 4 all raised to the power of minus 3 equals to 3 over 4 raised to the power of T minus 1. Now we are moving. What did you notice again now? You will notice that at the left hand side, we are having 3 over 4. At the right hand side, we are having what? 3 over 4. So which means that our exponential function is getting ready for us to get our answer. So I can take this up, I can take this up now. What am I going to have left? Minus 3 equals to T minus 1. So what are we going to do here? You collect like times to get your what? Your T. So minus 3 plus 1 equals to what? T. By collecting like times. So minus 3 plus 1 will give us what? Minus 2 equals to what? T. So therefore we can say our T is equals to minus 2. So try